In section 1.8, we're looking at one-to-one functions. First part of a one-to-one function is that for every x, there is exactly one y, and for every y, there is exactly one x. That's the first part. So whatever we have in our domain and range, if we have values of negative 1, 0, and 1 for the domain mapped to the numbers 2, 3, and 4, we're saying that this is one-to-one for each of these values, and that's what's going to be part of making this a one-to-one function. So now we already know that for a function that's going to pass a vertical line test, to be a one-to-one function, it's also passing the horizontal line test. Like we said, in a function, we already know that every x value's got exactly one y, but now for every y to have exactly one x, now it's passing not only the vertical line test, but also a horizontal line test. So if a function is one-to-one, then it will have an inverse, which we would write as the inverse of f of x. So for inverse functions, we already mentioned our original function we're going to write as f of x, and the inverse function we're writing as the inverse of f of x this way. Now there's some things that happen here with these inverse functions. First of all, the domain of the original is the range of the inverse, and the range of our original is the domain of the inverse. So any of the points that we write here as xy, then that would mean here they're going to be yx. Now what this also does then is we're going to have some symmetry between the graphs of these two functions. And they're going to be symmetric to the line y equals x. So for example, if we have a graph, let's say our original function, I'm going to draw in red, let's say that it's going from here through the origin up this direction, something like that. All right, now I'm going to try and mirror this over the line y equals x, so that what it looks like as we draw this is it's going to come around here doing the same thing, comes away, goes up that direction where we have it mirrored over that line where we're symmetric to that y equals x line. Now our steps when finding the inverse, first thing we're going to do, instead of writing it as f of x, we're going to change that to y. So if we have f of x is equal to 4 over x plus 2, we're going to rewrite that as y equals 4 over x plus 2. Second step, we're going to change the y to x and the x to y. So going back to this, now we have x is equal to 4 over y plus 2. Next step, we're going to solve for y. Alright, so here we would multiply both sides by y plus 2. So now we have x times the quantity of y plus 2 is equal to 4. Next we're going to distribute the x, so we have xy plus 2x equals 4. Subtract the 2x over, so xy is equal to 4 minus 2x. Divide by x, y is equal to 4 minus 2x all over x. Next step, we're going to change the y to our inverse notation for f of x. So going from this, now we're going to say that the inverse is equal to 4 minus 2x all over x. To check our work, if we plug the inverse value of x into our original equation f of x, when we simplify it all, it should come back to just equaling x. So for example, our original f of x was equal to 4 over x plus 2. And then we just found the inverse to be equal to 4 minus 2x over x. So if I plug this inverse value in for my x value here, so we're going to say that the inverse of x is equal to, so I have my original 4 over, and then in this x value I'm plugging in the inverse, so 4 minus 2x over x plus 2 this way. Alright, now first thing we would want to do here, when we're going to add on the denominator, we need to get a common denominator. So we're adding our fractions. I have 4 minus 2x over x. So I'm going to multiply here by x, so it's 2x over x. Now we can add these fractions. So I'm going to jump over here. So we have 4 over 4 minus 2x plus 2x all over x. Minus 2x plus 2x cancels out, so now we have 4 over x. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So we have 4 times x over 4. That's basically over 1. Cancel. We have x. We could also then check the inverse by plugging in the original. Solving it that way should also equal x.